Okay, here's my bottle rocket stove that I built. That's what I call it. It's out of a 20-pound propane bottle cylinder. Hence the name, bottle rocket heater. What I've done is I've taken 3-inch exhaust pipe here, and I've made the typical 90-degree in here, and I brought it about 7/8 of the way to the top, the chimney inside, and then it's obviously confined inside this cylinder, and then it goes through the box I built on the back and is exhausted outside, which this is the heat exchanger, if you will, or heat chamber. What I've done is I've taken the bottle and I've turned it upside down, and the ring that it sets on the ground on was a good level place to weld my plate to. It was only a 1/2 inch from the bottom of the plate to the top of the barrel. I took a 2x2 square piece of 1/4 inch metal, welded it to the barrel, and set it on top of this for a good heat transfer. That's a 1-ton rotor off of a truck brake job I'd done or something, so I saved it. The pictures that will be associated with this video are before the burn chamber. The burn chamber, I guess, is fine. It's turned out okay for its design. I'm not particularly happy with it. The next one I build, this chamber will be at least 6-inch for this size stove. You can build a lot hotter fire. You can get a lot of heat out of it. If this is not built into a mass heater, it won't hold much heat. We've got a rock here that's not finished yet. This will be brought to here and brought to here out and all the way around. The stone will be finished like the back. But that's the only heat retention we have in this, and the 1/4 inch plate and whatever the metal will hold for how long, which is not much. So you pretty much get heat off of this thing when you're running it. It's not, it doesn't retain heat well at all, like through the night or something. And this burn box is not big enough to carry any amount of wood for overnight. So this is usually heating and cooking. As you can see, I cooked my supper on it tonight. That took a stove that was warming up and a cold pan. Took about 20-25 minutes. So I'm estimating that if the stove was at optimal temperature and the pan was preheated, that it'd take roughly 15 minutes to brown the kielbasa sausage I made my sandwich out of, and so that's not too bad. The amount of wood that you see in there right now, these pieces are about 18 inches long. Back to the design of this box. I've seen this online before, and other people may have been able to do better with it, but it works okay. You got to stay on top of it. These pieces, for some reason, and I got an idea, I think I know why, but I'm not for sure. In the bottom of this box, the draft keeps the coals burn up so much and so fast that these sticks, actually, it'll burn the outsides off of them and it'll leave like a charcoal center on the end of this stick. If you don't keep this punched down to keep the coals built up in the bottom of this box right here, it won't continue to burn these things. They'll actually go out. And so I'm not particularly happy about that. I think the reason for that is, even though this is 1/4 inch plate and it will hold heat, it doesn't hold heat like it would if it was burning in the 90-degree angle in here, which is normally insulated on a stove. And in this heater, the best insulation it can get is the hot air that's surrounding that burn chamber that's in the center. So I think that has a whole lot with promoting the burn of the wood or the fuel that you're putting in it. So the next one I build will not have the vertical tube in it, or the horizontal tube. It will have a 45 into the vertical, and that way all this fire will go down in the hottest part of the stove. All this wood will go down in the hottest part of the stove, and that's where the fire will be, and I think it'll consume better, it'll hold coals better, I think it'll burn wood better. May be wrong, but we'll see. But all in all, if you stay on top of it, it'll burn. It'll create a lot of heat. I got in this evening, it was 31 degrees inside. I'm in an Airstream, 30-foot Airstream, and when I got in this evening, it was 31 degrees. and in about 55 minutes to an hour, I brought it to 67 degrees with just about this much wood, that's twice as much wood as you see here, about 4 sticks twice, maybe 7 sticks, 8 sticks. So not too awful bad, especially pine, you know, and it doesn't last very long. I don't have any problems with creosote. It seems to burn hot enough to don't have any issues. In an open firebox type stove, I've burnt pine for many, many years. Not had any problems, but I burn hot fires. I use pine to create heat, fast heat, instant heat. I don't stuff my stove full of it, smolder it down, choke it down, and then try to burn all night long with it and create heat with it overnight. I use hardwoods for that. But as far as burning pines, I never had any problem burning pine, as far as creosote and things of that sort, chimney fires and all that. Used a 15.5-inch mobile home rim to cut this top piece. All in all, I'm happy with it. I'm going to. My torch was a little small for 1/4-inch metal. It didn't blow the slag out. Didn't clean the groove out good enough to get a nice good cut on it. So I'm going to trim this with like a 1/4-inch flat plate all the way around it, and make it look a lot better. And then I'm going to paint it with a good quality paint. This area in the back here, I would eventually like to wrap a piece of copper tubing around that to create, you know, hot water. That is actually a slanted chrome tip off of a pickup truck, like dual exhaust. I cut the tapered end off of it and welded it on the box, and then inside that pipe right there is the 45 slash cut on the end of the pipe, so it worked perfect. I mean, the 4-inch pipe slid over it like a glove. So, you know, have no complaints. The bottle is upside down. The top has a hole in it where the valve was, just in case this chamber was to get too hot and want to sag or something like that. I chose to go up in the hole in the center, in the bottom, which is actually the top, with a piece of metal and push it against that, and then I welded it solid in the end of it. Cut the bottle off here with a cut-off wheel to get a nice clean cut to weld it back, and that's how I got my tube inside. Got a little slide door here in the front, and as you can hear, it's doing its rocketness. So, you know, I don't know if you can see the fire down in there or not. So it's doing its deal. I'm fairly satisfied with it. All but this thing here, I wish that was a little different, but it is what it is, and I can make it do. Make do with it. All right. Well, appreciate you watching this video. This is this is my bottle rocket heater, and just want to show it to you. All right. Take care.